The goal of this lab is to calculate the permeability of a specific sample. That will be accomplished using Darcy's law. This is the definition of Darcy's law right here. If a rock with a permeability of 1 Darcy is subjected to a pressure gradient of 1 atmosphere per centimeter, a fluid with viscosity of 1 centipoise will flow through each centimeter squared of its cross-sectional area at a rate of 1 centimeter cubed per second. This is going to be the equipment we're going to use for this specific experiment to calculate the permeability. This pump is going to pump the water out of the water tank. It's going to go through this line. Once this pressure stabilizes in the core sample, you'll slowly get a drip into this cylinder right here. Depending on the values of the pressure, time, that's how you're going to calculate your permeability. There's going to be multiple settings used, flow rate settings, so that way the permeability can be confirmed. Once you have those different permeability values, you're going to take the average, and that's going to be your average for that specific core sample. Permeability is the rate of flow of a liquid or gas through a porous material. That is important because for petroleum, in order for oil to be formed, that permeability has to be between a specific value, or the oil cannot be formed. Alongside Darcy's law, which is used to calculate permeability, we're also going to calculate resolution uncertainty, which is uncertainty from the equipment, standard uncertainty, which is the variation or dispersion of a set of data values, combined uncertainty, which is going to be your resolution and standard uncertainty combined, and error propagation, which is going to be the value that is going to represent how off your permeability will be. For example, if your permeability is 100 and it's going to be off by 1, your error propagation is going to be 1. So you're going to put that 1 over your permeability, multiply that by 100, and you'll get your percent error for your permeability. We're actually going to create a MATLAB code to be able to calculate your permeability. The 3 data sets that we're going to need, or the data values, are going to be the max pressure, the minimum pressure, and the time. This is going to be our algorithm for our code. We're first going to use our household commands. Input variables, we're going to use conditional statements to make sure that our data falls within a certain value. If it doesn't fall within that certain value, it's going to be automatically replaced and display an error message after 3 attempts. We're going to do all of our calculations. First, we're going to have to do conversions for about 2 or 3 calculations. We're then going to use all our calculations. After our calculations, we're going to ask if you have multiple data sets. If you do have multiple data sets, you're going to constantly go through a while loop. And you're going to, at the end of it, you're going to be able to see a chart with the relationship between permeability and flow rate setting. And you're going to get a plot of the average flow rate versus the average pressure to show if the relationship is linear. This is our MATLAB code. Of course, we're going to start off with our housekeeping commands. From line 6 through line 12, we're going to have hard-coded values that were given specifically for the equipment that we're using for this experiment. That is a limitation because we can't use any different equipment. It has to be specifically this size equipment. We're going to have a viscosity of 1 because that is the viscosity of water. We're going to start off with some empty matrices. The matrices are going to be used, for example, if you have multiple data sets, because if you have 2 data sets, you're going to have 2 permeabilities. So when you take the average of that, you're going to be able to get your final permeability. These other matrices are going to be used for the plotting later in the code. We're going to start off with one big while loop. First thing we're going to ask is for the user to enter the flow rate setting. We're then going to ask the user how many data points they have. This for loop is going to be able to show the data points as data point 1, data point 2, data point 3. Within the for loop, we're going to have a conditional. The conditionals are going to be different for the max pressure, minimum pressure, and time. If it falls within the right range, then it's just going to go ahead and skip the conditional. If it doesn't fall within the range, it's going to let the user know to enter a new value. If the user still enters a value that is not within the range, it's going to give an error again. If they do that 3 times, it's going to automatically give a value for that data point for the user. For example, for the max pressure, it's going to be 73. For the minimum, it's going to be 37, and for the time, it's going to be 164.9. These are going to pretty much run the same. They have conditional for loop exactly the same for those minimum, maximum, and the time. So after the for loops, and after we're going to be going to the conversions. The only conversion we're going to be using is for the pressure. It's going to start off with PSI. We're going to go ahead and make it change it to atmospheres. Where they're going to have all our calculations. All of our calculations are going to be done in functions. We have created functions for every single one of those 6 equations that we're using. After the calculations are done, we're then going to have a menu show up that's going to ask the user if they want to input another data set. If the user says yes they do, then again it's going to equal 1. Because it equals 1, the while loop is still going to be, the requirements are going to still be met. So it's going to be go ahead and do that whole while loop again. If the user clicks no, then again it's going to equal 0, and that while loop does no longer meet the requirements. So it won't go through it again. After that while loop, it's going to print out on the command window your flow rate setting, your permeability, and your percent error specifically for that flow rate setting. You're then going to get 2 plots. One plot's going to be the permeability and flow rate setting, and you're going to get a linear relationship between the flow rate and average drop of pressure. In order to have the linear relationship, you're going to have at least 2 data sets. If you don't have 2 data sets, then it's not going to show up as a linear line. If you have 2 data sets, then it's again going to print out up here. So if you had flow rate setting 5 and flow rate setting 7, you'd have 2 of these. But then that means you're gonna have 2 permeabilities, 2% errors. So it's then at the very end, it's gonna print out the average of those 2 values. So if you have 2 data sets, it's gonna take the average of the permeability, it's gonna take the average of the percent error, and that's also along with the figures, these 2 values right here, and the permeability and percent error specifically for flow rate setting is all going to be printed out on the command window. So now we're going to look into actually running the code. This is the data that we're going to be using for our code. We're going to have different data sets, data set 1, 2, 3, 4. So now we're actually going to run the code. The first thing we're going to do is verify that you can enter as much data points as you'd like. So we're going to go ahead and go with 75 for the first time, just give an example. So as you can see, it's going to go until you get to 75. Another thing we're going to show is if it's out of the range. So it's going to tell you that it does not fall within the range. As we stated earlier, it's going to give you the message 3 times. Once it gives you it 3 times, it's going to be automatically corrected to a certain value. For this max pressure, it's going to be automatically changed to 73. So for data point 11, it's going to be automatically changed to 73. We're going to go ahead and do the same thing and show that it gives you the warning once. If we change the value to something that meets the requirements, it's going to go ahead and save that value for that data point. So let's go ahead and rerun the code. We're going to go ahead and just enter 1 data set and see what is outputted on the window. This data is from that data set that we saw previously. So this one's going to be 34, but it's automatically going to be changed to 37, so we're just going to go ahead and do that. Save us some time. That's going to be for data point 3 and data point 4. This is going to be working the same way. It's supposed to be below 165, so we're going to go ahead and just automatically change it to 164.9. The software that I'm using is actually not going to show another window, but there's actually a menu right here. It's going to ask you, do you have another data set to input? And for this case, we're going to go ahead and say no. There's going to be 2 graphs that appear. The first one is flow rate versus change. Because there's not 2 data points, it's just going to go ahead and be a flat linear horizontal line. And there's going to be 1 data set on this flow rate setting versus permeability. It's going to tell you for that specific flow rate setting. So for flow rate setting 5, you had a permeability of this, percentage error of this. Because there's only one data set. The overall average is going to be the same exact for these two right here. And run the data set again, but this time we're going to go ahead and do two data sets. Now the data set one's in, it's going to ask us again. So we're going to go ahead and click yes, we want to enter another one this time. I'm going to go ahead and flow rate setting 7. It's then going to ask us again if we need to enter another data set. We're going to click no. Now it's going to give us a linear line because we have two data sets that we're actually looking at. For the other plotters, they're going to give us 2 data points. For the flow rating setting 5, it gave us the permeability and percentage error. Did the same thing for the flow rate setting 7, gave us the permeability and error. The overall, which is just going to be the average of those two, is going to be 0.180, and the average percent error is going to be 0.378. And that's basically how the code runs. When it comes to limitations and applications, this code alongside the equipment could be used to determine the permeability, which could determine if a specific sample is capable of holding oil. When it comes to permeability and oil, usually the permeability has to be high, so engineers could use this to test rock samples from different locations with this equipment, and it could give them a automatic answer, because if you have a permeability that is extremely low, then you know there's absolutely no chance. But if you have a permeability that's sort of high but really high, I mean just anywhere between that area, then there's actually a chance that there could be oil there. So it actually allows the engineers to test for that, to be able to continue to test for oil, instead of a place that is really low permeability, they can automatically just throw that out the window. When it comes to limitations, there's really only one main limitation, which is that an engineer would have to use this specific size equipment given. You cannot use any size of this identical equipment, even if it's proportional to that equipment. It cannot be used because the calculations that are going to be given from this code are going to be incorrect.